Today's lesson is on proportional relationship. So we are talking about relationship, in particular relationship between numbers, quantities. In our real life, sometimes a quantity relates to another quantity. For instance, the temperature in Celsius relates to the temperature in Fahrenheit. Or my salary also relates to how much time I work. So quantities are related to one another. Sometimes a quantity controls the other quantity, just like how much time I work controls how much money I earn. And before we look into this particular kind of relationship, the proportional relationship, let's get ourselves familiar with some of the terms that we have learned before, because we'll be using those terms quite a lot in describing proportional relationship. The first one is ratio. Do you still remember what ratio is? Okay. Ratio is a comparison of two quantities. So for example, let's say in my classroom, I have 12 boys and 10 girls. Then the ratio of boys to girls in my class is 12 to 10. And sometimes we use different notations to indicate the ratio. We can use colon or we can use a fraction. And a lot of times we simplify ratio, especially to its lowest term. So 12 to 10 is the same as 6 to 5. So 12 over 10 is the same as 6 over 5. The other term that we need to familiarize ourselves with is proportional. Okay? Do you still remember what proportional is? Well, proportional is used to describe ratios. So if I have two or more ratios and I say that they are proportional if they are equivalent. Remember this previous example between 12 over 10 and 6 over 5? These two fractions are equivalent. So these two ratios are proportional. Another example, I have four ratios here, and all of them are equivalent to one another. 1/3 is the same as 2/6, same as 10 over 30, same as 18 over 54. So I can simplify all of them and then to reduce to the lowest term, which is 1/3. So all of them are equivalent. So all these ratios are proportional. Okay, so now let's give definition to proportional relationship. It is a relationship between two quantities in which the ratio of one quantity, let's call it y, to the other quantity x is constant. Okay, so the crucial point here is the ratio is constant. The ratio of these two quantities is constant. So one quantity is y, the other quantity is x. So y to x, or y over x, is equal to a constant we call k. K for constant, meaning it doesn't change its value. And we can use an equation to describe that relationship. And that equation is y equals to kx. Y, we just keep it by itself on one side, and then kx. This equation is equivalent to this equation up here, because I can obtain this equation just by multiplying this equation by x on both sides. And then I will have y, and then x cancels out with the other x that I multiply, and then k times the x. Okay? And this constant k is called the constant of proportionality. Okay? So k is a constant. It has a special name for this special kind of relationship. Okay, let's take a look at one example. Mark earns $15 an hour at his part-time job. Show that the relationship between the amount he earned and the hours he worked is a proportional relationship. Write an equation for the relationship and use a graph to represent the relationship. What characteristics does the graph show? Okay, in working with word problems like this, and sometimes we like to use equation to represent it, represent like a word problem that describes some relationship. And we also a lot of times we use a graph to visualize the relationship. So equation and graph and then verbal description, they all tie to one another closely. Okay, so let's try to solve part A. Let's show that the relationship between the amount that he earned and the hours he worked is proportional relationship. Okay, we can use a table to help us here. So in this table, I'm going to list the number of hours and the amount that he earned. Okay, so let's say he worked for 1 hour, then he earned $15. If he worked 2 hours, then the salary is $30. And for 5-hour work, then he earned $75. If he worked 10 hours, then he earned $150. Okay, so just give some examples of, how many hours worked and how much dollar amount earned. And then the next thing that we're going to look into, because we're going to determine if the relationship is proportional relationship. So we're going to compare the two quantities, the amount earned and the number of hours. We will compare them. We'll find the ratio between these two quantities to see if it is a constant. Okay. So let's look at the amount earned and number of hours. So for this column, the amount earned is $15. The number of hours worked is 1. So the ratio here is 15 to 1, all right? Because we're talking about amount to hours. This is amount, this is hours. So 15 to 1 for this. If he worked 2 hours and he earned $30, then the ratio is 30 to 2. And the next one is 75 to 5 and 150 to 10. Now let's take a closer look at all these ratios. Okay. And do you realize that this ratio here can be simplified to become 15/1. Same for 75/5 is also the same as 15/1. And same for the last one, 150 to 10 is also the same as 15/1. So now that we see that all of them are the same, all of these ratios are equivalent. And by the definition of proportional relationship, this is a proportional relationship because all the ratios between those two quantities is constant. Since the ratios of the quantities are always 15 to 1, therefore the relationship is proportional. Okay, so this is our conclusion for part A. So now we answered part A. So let's continue with part B. Write an equation for the relationship. Okay. In order to write an equation, I understand that my equation has x, has y. So let's give some definition to x and y first. I'm going to define my x to be the hours Mark worked and y be the amount he earned. Now you may wonder, why did you pick x to be the hours worked and y be the amount earned and not the other way around? Okay. When we are dealing with relationship, sometimes one quantity depends on the other one. Especially in this particular example, the amount that he earned is controlled by the hours that he worked. So y is used to represent the dependent variable. Most of the time, all of the time, y is used to represent the dependent variable and x is the independent variable. So this is the independent variable and y is the dependent variable. All right, we notice that the equation is in the form of y equals to kx. Remember the first slide that I showed you? Y equals to kx. Okay, so I have y and x already defined. What about the value of k? What is k? We need to figure out the value of k so that we can complete the equation. Okay, that's not too hard because in order to find out k, this is what I'm going to have. K is equal to y over x. Remember we saw that in the first slide. Or you can just divide both sides by x here. Divide both sides by x. And then you can single out the k. And then just find the ratio of y to x. That will be the answer for k. So y over x, this ratio is k. But what is y? What is x again? Y is the amount earned, right? The dependent variable. And x is the hours worked, which is the independent variable. In our previous slide, we saw that it's always 15 to 1. So do you see that y over x, which is k, the constant of proportionality, is always 15 to 1, right? So now we figure out the k, so we can put it back into the equation. So we say that y equals to 15x. Okay, let's move on to take a look at the graph of this problem. Okay, we will use a graph to represent the relationship and find out the characteristics from the graph. Okay, in order to graph the relationship, I'm going to use a table with some values to help me find those points. Again, I can use the same table that I used for part A. So remember, I got these values. If he worked 1 hour, then he earned $15. 2 hours work, $30. 5 hours work, $75. 10-hour work, $150. So I'm going to use these to help me graph the relationship. Again, what is the x-axis and what is the y-axis? Remember, the amount depends on the hour. So hour is independent. So hour is going to be our x, and amount is going to be our y because y depends on x. Y is the dependent variable. So now we know on which axis we're going to use for hour and for amount. So let's continue with the graphing part. So I'm going to have a graph like this. Okay, so basically I just locate those points. X is 1, y is 15. So x is 1 is here, y is 15. So you see that this is like 50. So each square represents a 10. So 15 is between 10 and 20. So that corresponds to x equals to 1. So 115 is right here. The other point is 230. So 1, 2, right? Because for my x-axis, I use 1 square to represent 1. So 2 and 30. So this is 10, 20, 30 right here. And then the next one is 575. So 5 is right here. I need to go up to 75. So this is 50, 60, 70, and 75 is right in the middle here. And then the last point is 10, 150. So this is 10. Go up here. This is 150. So now I located these 4 points and I can just join them to form this line. So what do you notice in the graph of a proportional relationship? Do you notice this, that the graph of a proportional relationship is a line? Yes, it's a line. It's not curvy, right? It's straight, okay? It's straight. And not only that, it also passes through the origin. So this is the origin. So if Mark didn't work at all, he did not get any pay at all. Okay, so it passes through the origin. So that is the characteristic of a proportional relationship, that you always get a line, which is a straight line, of course, and it always passes through the origin.